Let's have a look at the output of this program. In this program we have 7 threads. There is the main thread, and these are the 6 additional threads that have been formed. The function thread function is going to execute independently with a separate copy in all the 6 threads. When compiling this program, I named the executable th88. You can name it anything else. When I execute this program, the output shows that thread 1 was able to complete from iterations 0 to 6. This means the for loop in thread 1 is not complete and it has been scheduled out. And then we see thread number 4 executing, and all the iterations from 0 to 9 of the for loop are able to complete. The line by from 4 is displayed by thread 4 just before it calls pthread exit. After that we see that thread 0 is scheduled and it is able to complete all 10 iterations of its for loop. Then thread 2 is scheduled in and it is able to complete all 10 iterations. This line is displayed by the main thread after pthread join returns. This line is displayed by the main thread. And next we see that thread 5 is scheduled in, it completes execution, and after thread 5, thread 1 is again given a chance and it is able to run and complete its iteration and terminate. And then we have thread 3, and finally that completes the program. Because thread scheduling is done at runtime, we would expect that this program would give a different output if it was executed a few times. Therefore, it is no surprise that when this program was executed a second time, we have a different sequence of output. We have thread 1 able to complete all iterations of the for loop, then followed by thread 0. Then we see that thread 3 was scheduled. It was only able to manage 2 iterations and it was scheduled out. Then we had thread 2 given a chance to execute. It managed only 4 iterations before thread 4 was scheduled in. And this keeps on happening until all threads are scheduled in, eventually getting a chance to complete, and the program is all done. Finally, a third time when this program is executed, there is yet again a different sequence. We see that thread 1 was able to only complete the 0th iteration in the for loop. Then thread 2 was able to manage from iteration 0 to 4. Then thread 0 was able to run all 10 iterations. Then thread 1 is given a chance, it is able to complete. Then thread 2 is given a chance to complete, and so on until this program has all the threads completing and the program is done. The reason for this varying output is because of scheduling. Scheduling is something which is done at runtime. Therefore, this is no surprise at all. In many cases, when we have multiple threads executing, we want them to sort of proceed further in a marching manner. What this means is that we want to enforce a discipline that all threads should sort of proceed further at roughly the same rate. In this specific example, we might say that we want all threads to complete the 0 iteration of their respective for loops, and only after all threads have completed the 0 iteration of their for loop, then every thread should complete iteration 1 of their for loop. And only after all the threads have completed iteration 1, only then they should proceed and perform iteration 2 of their respective for loops. And in this way, ultimately, they should march together and proceed at roughly the same rate. How can the threads be synchronized to execute in this manner? Can semaphores be used to achieve the desired result? Or is there a more simpler and more elegant solution out there for such kind of synchronization requirements? Fortunately, there is such a solution out there when threads must be synchronized in the way just described, and that solution is called barriers. So next, this example would be modified and barriers will be included to enforce the discipline of threads moving together.